Hi everyone, so this is question 6 tutorial sheet 3 under complex numbers. So the question is express each of the following complex numbers z in rectangular form. So question 5 was talking about expressing it from rectangular to complex. Now this one is vice versa, it's the opposite. So we're going to start with the first question there, and I guess maybe just me doing the first question and probably the last question there will help, because the rest of the questions there are just the same, because the way you do these questions is just the same. In fact, I can only do the first question there and it will be good for you, so that we do a lot of questions at least today. So I'm going to do question 6i and probably even question 4. So the first one here is saying z. So I'm equating all these complex numbers to z, because they've been taught to say these numbers are z's. So 4, then open brackets, this is cos 4 pi over 3, then plus sine 4 pi over 3. So these are the complex numbers that we have. This is the complex number that we have. So what you do is so for you to calculate this easily, I would advise you to convert this angle to degrees. And we all know, because when you say cos 4 pi over 3, some of you don't even know what this means. So the best is you convert the angle to degrees so that it becomes easier for you. So I know to say 1, or rather pi, let me just say pi in radians is just equivalent to 180 in degrees. So pi in radians is equivalent to 180 in degrees. So I'll put this 4 pi over 3 where there is pi this side. So 4 pi over 3, and then this one will be equivalent to what? X in degrees. So what I'll do is I'll cross multiply. So when I cross multiply, just here, if I want, I can cancel out this. Okay, I can, if I want, I can put a division line there, and I'll put a division line there such that this pi and that pi will cancel. So I'll remain with 1 here, and I'll remain with 4 over 3 down. So I'll cross multiply 1 times x, my answer there will be x, and then this 4 over 3 times 180. So in short, what I would do here is just this okay, let me just write it here so that I show you the simplest way and fastest way of solving such questions. Times 180. Since you don't have a calculator, before you multiply 4 times 180, this is 3, not 8, sorry. This is 3. Alright, so before you can even start multiplying 4 times 180, you get a bigger number which you fail to divide by 3 again at the end. So the best way is first you divide this 3 into 180. 3 into 3, 1. 3 into 180, you get a 6. So meaning you have plus this 0 there, you get a 60. So meaning you're going to have a 60 there. So 4 times 60, your answer will be 240 degrees. So 240 degrees will be your answer. So here, this question is just the same as putting a 240 degrees there. So I'll have a 4 there, then open brackets, this is cos, so this is just the same as cos 240, then plus sine 240. So now we can proceed here. So this is just 4. So this angle 240, we can write it again in a way that it is going to be easier for us to know what we are doing, to know. Okay, let me just do it quickly here. So cos 240, if I write the XY plane here for quadrants, we know that A, this side, O, soldiers take cab, or all students take coffee, whichever way you master it. So the thing here that you're supposed to do here is you look at this 240. This 240 will be like this. It's starting from here, so you move here 180, so 240 is going to be somewhere there. So it's going to be somewhere there, so meaning it's in the third quadrant. So if 240 is in the third quadrant, so if this is in the third quadrant, you find this angle here. So this angle, you just say 240 minus 180, because here we have 180 this side degrees, then this is 0 and 360. So this angle here is going to be 60. How do I know? I know that when I'm in the third quadrant here, I'll just say 240 degrees minus 180. I want to find this theta there, this one. So this theta, to find this, you just subtract this 240 minus 180. So that is what we call the terminal angle. So this terminal angle is the one that we're going to replace there. So it's going to be cos, but of course, since this one we're dealing with cos there, and then cos in the third quadrant is negative, it's not positive. Cos is only positive in the first and in the fourth quadrant. So now, since cos is negative in the third quadrant, I'm going to put a negative there. So I'm going to say negative cos 60, and then here let's now deal with sine. Sine here is there. So we know that the terminal angle is 60. So the terminal angle is 60. I will write it first like that before I start dealing with it. Like that. Now you can ask yourself, is sine negative or positive in the third quadrant? It is going to be negative, right? It's going to be negative. So here, instead of putting a plus here, I'll put a minus. Let me just delete this. Sorry for deleting it in this way. I'll put a minus here, 60, minus sine 60. Why? Because sine is negative in the third quadrant. I put a negative here because cos is negative in the third quadrant. So it's going to be something like this. So open brackets. So cos 60, we all know to say it is a half, which is plus this negative there. We're going to have negative 1/2. Then minus, we know that sine 60 is nothing but √3/2. So now we can simplify this. So simplifying this, 4 times that, 4 times half, you get -2, and then there 4 times negative root 3 over 2, you get negative, oh sorry, I forgot to put I there. I don't know why I'm forgetting to put this I. Okay, so it is going to be negative I, or negative 2, negative, let me do this. So it is going to be, when you multiply this times that, you're going to have 2 root 3. Then you put the I outside there or in front, whichever way you prefer, as long as you know what you're doing. So this is how you solve such kind of questions. This is how you solve such kinds of questions. So same applies to all the remaining questions. You can do the same. So looking at the way these questions have been phrased here. So this is our Z in rectangular form. So we can also, I think I can also do question 12. Oh sorry, question 6. Yeah, I'll skip these because they are too straightforward. Or maybe I do question 3. Let me check first which one looks at least a little bit complicated. Anyway, let me do question 4, not question 6, but question 4. So question 4 here is Z is equal to 12 open brackets cos pi over 12 sine pi over 12. Actually, I'm not the only one who is leaving I there. Even the one who was typing left it. So, but it's supposed to be there. So this is cos pi over 12 sine pi over 12. Cos pi over 12, and then sine, there's supposed to be I there, sine pi over 12. So the first thing here, when you are changing these things, you first convert your angle to degrees. So this angle in degrees is there. You use the same formula that I'm just from showing you, which is this pi is equal to, so this pi is equal to what in degree? It's equal to 180, and then this then what we've been given here is pi over 12. So pi over 12 is going to be what in degrees? We don't know. We put x, so we cancel that pi and that pi. We cross multiply there. We're going to have 1 times x. We're going to have x, and then this is well, we remained with 1 over 12 there. 1 over 12 times 180. So 1 over 12 times 180 is going to give us, so it's going to give us 15 degrees. So this is going to give us 15 degrees. So in short, this question, in other words, you can write it as 12 cos 15 I sine 15. So it's going to be like this. Cos 15 degrees, then plus I sine 15 degrees. I sine 15 degrees. So Z is equal to, we put 12 there, then open brackets. Remember compound angles. So compound angles, remember what we are solving in trigonometry. We said, let me just draw a simple box there. So we said cos 15 can also be found by what? So cos 15 can also be found by saying cos by finding cos 45 minus that compound angles. So you're just building on what you already learned. And then sine 15 is the same. Sine 15 is equal to sine 45. So sine 45 minus 30. When you subtract 45 minus 30, you get 15. So this is how you find these angles there. So I don't know if I should find them. Anyway, let's do them quickly. I'll write them this side. So cos 15 there, cos 15 is equal to this. So cos 45, so cos 45 minus 30, cos 45 minus 30 is nothing but, first you start with the same trig ratio. So it's because 45 and then cos 30 cos 30. So cos 45 cos 30 plus, if there's a minus here for cos, it's negative, it will be different, so it will be plus sine 45 then sine 45, sorry, then this is sine 30. Let me just put one in brackets like that. Cos 45 cos 30 sine 45 sine 30. Then you start putting in the values now. So cos 45, so cos 45 is cos 45 is the root of 2 over 2. You put it in brackets. Then cos 30 is root 3 over 2, and then plus sine 45. I think this one is just the same, root 2 over 2, and then you open the bracket. Sine 30 is 1 over 2. Then you calculate this. This is root 6. So this is root 6 over 2 times 2 is 4. Then plus root 2 over 4. Root 2 over 4. So this is our cos 15. So this is our cos 15. This is our cos 15 degrees. Let me just write it properly. Okay, this is our cos 15 this side. So cos 15 is equal to, this is our answer. You can even simplify it further to say it's root 6 plus root 2 over 4. Let us now find sine 15. So sine 15 is equal to sine 45 minus sine 45 minus 30. So we'll start with so this is going to be sine 45 going to be sine 45, and then cos sine 45 cos 30, and then minus sine. If there is a minus there, even there should be a minus. Remember what I said, sine same, minus, then sine, we switch the angles. So this is going to now be sine 30, and then cos 45, then cos 45, like that. And then so our sine 15 there, we put in the value sine 45. We know that is the one that we said is root 2 over 2. And then we'll open the brackets, cos 30 root 3 over 2. Sine 30 is half. Oh, it's not a minus, it's supposed to be, it's not an equal sign, it's supposed to be minus. And then this is sine 30 is going to be 1 over 2. Then you open the brackets, cos 45 will also be root 2 over 2, like that. So this one you get the same thing. This is root 6 over 4, and then minus root 2 over 2, which gives, over 4, which gives root 6 minus root 2 over 4. So these are the solutions. So this is sine 15. So from there we can now go and put them in the, now put them here. So cos 15 we found to say it was root 6 plus root 2 over 4, and then plus our I there, and then what is now the sine of 15. So sine of 15 we found it to be the root of 6 minus root 2 over 4. Put it in brackets like that, and then close with curly brackets. And then you multiply throughout by 12 now. So you can multiply throughout by 12 to find z. So now my z is just going to be, this is just the same as 4 into 12. We multiply 3 times 4 into 12. I'll just cancel this 4 and that 4, and then and that 12. 4 into 12, I'm getting 3. So I'm just multiplying 3 with everything there. So I'm going to have 3 root 6 plus 3 root 2, then plus, so 3 root 6 plus 3 root 2, then plus 3 let me just leave it outside like that, open bracket, root 6 minus root 2. So this is z, this is my final z. So this is how you do also the remaining questions. So this is the reason why I did the simplest one and the hardest one on these questions. So meaning the remaining questions are simpler than what I've done, which implies that you can even do them without even finding any complications. Otherwise, if you find any challenges or any complications on any of these questions, you can contact me on WhatsApp on this line, and make sure that you subscribe to the channel so that you don't miss out the videos that I'm going to be posting on certain tutorial sheets and test papers that you're going to be writing for revision sake. Alright, see you next time in the next tutorial video.